Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Everyone, I welcome you back to Global Education Zone, and today we'll be dealing with another episode of our Crash Mathematics for SS2 course. Now, in this particular course for this video, and this particular episode, we are going to be talking about measures of dispersion. Now, up till now, you've talked about measures of central tendency, and measures of dispersion is another part of a broader topic known as statistics. Now, this statistics divided into measures of central tendency, and measures of central tendency is divided again into your mean, your median, and your mode. Now this time around we are dispersing away, or we are deviating from measures of central tendency. And measures of dispersion, they are simply those measures they are used to calculate the amount and the degree of which your data have deviated or have separated from your central value. So your measures of dispersion, they are like your dispersions from your central tendency. Now these dispersions, they are different formulas and different terminologies associated with measures of dispersion. For example, we have the range, which is the difference between the highest and the lowest term and the lowest value of the data. We also have the standard deviation. We also have the variance, which is the square of the standard deviation. Then we also have as mean deviation. Your mean deviation is the sign with the sign, that is the with respect to the sign, the summation of deviations divided by the total number of values. So now let's delve into the main part of this video and let's talk about this in detail. Now first of all, we'll be starting with range, and in this aspect of range, we'll be talking about what range is. And the range of a set of numbers is that difference between the largest and smallest numbers. So this is the first measure of dispersion, and by far the simplest. So all you need to do is need to know the difference between the largest and the smallest. For example, in this question, we have find the range of the following set of marks of 79, of 60, of 52, of 34, of 58, and of 60. So now you can see that if you examine this data very closely, the largest of this data is 79 and the smallest of this data is what? 34. So the range is basically the difference between your 79 and 34, the positive difference between 79 and 34, and your range so far will be equal to 45. So the range of that data, which is the difference between the highest and the lowest, is equal to 45. Now that's the first measure of dispersion. And now let's go on to the next measure of dispersion. Now the next measure of dispersion we'll be talking about is your deviation from the mean. Your deviation from the mean is basically gotten by when you sum your deviations from the mean. Basically, your deviation of the mean is gotten from when you subtract your mean from every value of your statistics data. So for example, if you have a statistics data of different values, for example, let's also assume we have a table 19.2, this table here, and then we have the mean of this table as 60. Now we have all this data 65, 62, 62, 61, 61, and so on. Now our deviation from the mean will be equals to each of these data will subtract the mean from each of them. So for example, for the first mark we have 65, and then the deviation will be 65 minus the mean, that is 65 minus 60, which is plus 5. Our deviation is plus 5. For the second one, our deviation is plus 2. So you can see that these are deviations of all the marks from the mean. So that deviation, when you sum the deviation together and divide by the number of data, is called mean deviation. So it's simply the mean of the deviations, and the mean of the deviations is given by the sum of deviations over the number of deviations. So that is how you get mean deviations. That's the formula for it. So we'll also be treating that questions on that. Next, let's talk about variance. Your variance is also known as your mean square deviation. That is the mean of the square of the deviations. So what you need to do is you look for the square of the deviations and look at the mean of those square of the square of the divisions. So for example, for in this same data we have here, we could, for these deviations for the mean, you will just square each deviation, then you add them together and then divide by the number of deviations. That's what's known as mean squared deviation, or you can call it the mean of the square of the deviations. So this is a condensed way of referring to variance. So mean square deviation also means the mean of the square of the deviations. Now the formula for variance, that is it here. It is the summation of the deviations, summation of the square of deviations divided by the number of data. Now lastly, let's talk about the last measure of dispersion, which is the standard deviation. The standard deviation is another important measure of dispersion. Although the previous measures are useful and simple to calculate, standard deviation is the most commonly used, most helpful and most reliable method of deviation. So, and it's derived from variance. So your standard deviation is basically the square root of your variance. So that's the square root of summation d square over summation f, or summation d square over summation n, where n is the number of data and your d is your deviation from the mean, and then your summation is basically when you add things up. In mathematics we call it summation. Summation is basically adding of things up. Now let's deal with this example. Calculate the standard deviation of the set of numbers 2, 5, 6, 7, 3, 8, 9 and 8. Now for this question, as you can see, the first thing we are going to do is we are going to look for the mean, because it's only after we've gotten the mean that we are going to be able to calculate the deviation from the mean. So the mean in this case is the summation of data over the number of data. So when we sum all the data, we have 48 divided by the number of data, which is 8. So our mean is 6. Now we'll go down again. We are going to begin to subtract the mean from each of the marks or the numbers. So for the first number 2, we subtract the mean from it. That's 2 minus 6. That's minus 4. Then when we subtract for every data, we are going to square that deviation, which is the subtraction. So when we subtract it, in the third column of this table, we have it as d square. So d square is 16. 1019494. So those are the values under the square. And then when you find the square root of the square of the deviation over the number of data, that's root 44 over 8, you get this standard deviation. So don't forget this, the formula for standard deviation is summation d square over n. That's the square root of summation d square over n. So, and having said that, that's majorly what we'll be covering in this video. Standard deviation. We've talked about range. We've talked about variance. We've talked about standard deviation and mean deviation. Now your standard deviation and mean deviation, they are tied together. Your standard deviation is the square root of your variance. So if you know your variance, you can get your standard deviation. For example, in the question I gave earlier, where we had a standard deviation of 2.35. Now your variance will be the square of 2.35. So that's simply how variance and standard deviation works. And today I've talked about the fact that standard deviation is the standard of dispersion, because it is mostly used for measuring the dispersion of data from the mean data. So thank you for watching and see you next episode.